Hey guys, my name is Sandeep Patel. I'm a founder of Slotify.ca. In this video, we are going to learn a simple algorithm to short array data structure. This algorithm is called bubble short. It's a really simple algorithm for shorting. It's used for array data structure. You can basically short array in ascending or descending order. So let's take an example. We have example here 53842. So there are 5 elements in the array that we want to short in either ascending or descending order. So using bubble sort, how can we short this, right? So let's take a real life example. Let's say there is a lineup of 5 people, right? And they're standing in the line with uneven height. And then you want to organize them in such a way so that the first person in line has the first person in the line has shortest length, and then it goes in ascending order, right? When we short this line. Okay, so here's how we can start. So let's say we start with our initial um, lineup, right? The idea is that we will start with 2 person at the time, right? So first time we compare first 2 people and see which one has a lesser height. The lesser height person will go on the left side, and then once we do that, then we compare the next 2 people in the line, right? And then okay, in this case they're already in ascending order, so there's nothing we can do. Then in the next move we can compare these 2 people and then swap the person um, from the left to right because they're in increasing order, right? So at the end we'll compare last 2 people and then um, put the person with the highest height on the right side. So in the first so this is a first pass. So in the first pass we got the person with the highest height on the right side. So now this person, once we sort this, it's gonna look like this, right? And then we can again start with the first person and comparing it with the second, and then we move on in such a way, right? So if you look at the end, we'll have everybody's organized in from short to largest height in the ascending order, right? So what we can say from this shorting, so we had initially 5 people in the line, right? So what we did is we let's say that like how many times we swap, right? So there are 1 2 3 4 5, right? So there are 5 times we went in the horizontal line, and then vertically we went like 0 1 2 3, like a total 4, right? So this you can say that from 0 to 4 it is less than n, right? And when we do 0 1 2 3, which is less than, I would say, n minus 1, right? So basically this is a loop, right? So this is a first loop that goes from 0 to n, and there's a second loop that goes to 0 to n minus 1. Also notice that like after each pass, so let's say once we're done with the first pass, right, in the next pass the person on the right side was already shorted, right? In the second pass the person on last 2% was already shorted, and in the third pass last 3% was already shorted, right? So what we can say is that like each time, let's say in here I equals 0, right? So in here there are 0 elements shorted, right? When I becomes 1, right, then you can say okay, there's 1 person already sorted, so we're not gonna go through that person again, right? In here it's I equals 2 and I equals 3, right? So you can say that when we are looping this we are basically doing n1 minus 1, and we can also exclude minus I, right, because I person is already shorted. So basically we're doing the shorting using 2 simple loops. So let's write the code and we'll understand. All right, so as I said in the first pass, whenever I say past, I mean we're going through a loop, right? So let's say that we need first loop, so first loop runs let I equals 0, I less than n, I plus plus. Let's say the n is, we can say, let's say constant n equals num array dot length, right? So that's the first loop I showed you here. It runs from 0 to until less than n, right? Go back here, and there's a second loop that goes from let j equals 0, j less than n minus I minus 1, j plus plus, right? You can see that here it's gonna go from 0 until less than n minus 1 minus I, right? And what do we do here? So when we are doing this, what we essentially want is to compare the current j with its next j, right? So num array j plus 1, right? So basically comparing two person in the line, right, from the ith position, right, or a jth position, right? And then once we do that, and if this condition is met, we basically want to swap this, right? So in JavaScript you can swap like this. So we're swapping j with j plus 1, and equals num array j plus 1 with num array j. Alright, so this is how we can swap when we find that the person on the left side is greater than the person on the right side. Swap the person, right? So basically that is it. So let's return the same array, right? And let's check the output. So when we pass 53842, so this is not sorted, and it should be sorted in this order. So as we can see, it's sorted in the correct order, right? And so we need to know the time and space complexity of this sorting algorithm, right? Okay, so basically when we calculate the time complexity, all we care about is, so Biko says that we're only concerned about time complexity if the statements are, let's say, if input size is growing, right, in terms of time, right? So basically means that if any of our code, right, if it depends on the number array, I mean the input, then we're concerned about that particular piece of code, right? So let's say this statement, right, this statement right here, it's not dependent on input. Like no matter how many times you run this code, it is going to have a static value, right? For example, if we are passing 5 elements when this run, this is going to have n equals 5, right? It's not growing in size, so that's why we consider that as 1 unit of time. Okay, so this loop is dependent on input, right? So it's starting from 0 and goes up to n, right? So anytime, let's say if you're running for 5 element, it's going to go from 0 to 5, right? If you have maybe 10 element or 15 element, this is going to run from 0 to 15 element. That means it is growing when the input size changes, right? So it's going to grow until 0 to n. That means n iteration, right? And also this one is also going from 0 j equals 0 to j n minus I minus 1. We can ignore this. It's still like n iteration. So let's say even though it's n minus 1, you can also say it's n minus I, but we can ignore that, right? And we can take the highest term. So we have two loops, and then there's this operation here. So this statement takes, let's say, 1 unit of time, right? um, so basically this is a constant time, right? No matter how many times you run this code, if it has j and j value, let's say 0, and then this is 0 plus 1, um, and it's doing the same thing here, right? Like it's a 1 unit of time. However, it also depended on this for loop. So if this for loop runs n into n time, that means n square time, then this statement will also run n square time, right? So that's the reason why the complexity of this for loop, right, the outer for loop is n square time, right? And that's the biggest complexity in this code, right? We can also find out the complexity of this guy is 1 unit of time as well. It's not dependent on input, but according to big O, we are only concerned about the bigger term. So what is the bigger term in this whole code, right? That you can say on square right here, right? Like this statement is running O of n square time, and that is what we're concerned about, right? And so we can say time complexity of this code is O of n square, right? What is the space complexity? So space complexity, we look at the temp auxiliary space that we use inside this function. So where is that? So when we define a variables, we should check if those variable depends on input size, and if they grow according to input size, right? So in here, this variable is a static variable. It's not growing with, it doesn't matter, like let's say even if number array grows to 1 million, this n value will be 1 million. It's not growing from 0 to 1 million, right? It's just a static value. That's the reason why we can say this is 1 unit of space, and this, we don't use any variable here. So this is like temporary swapping happens, but we're swapping using the same input array, so we're not counting that. Also this one, that we're returning the same input, so we're ignoring input when we are counting towards space complexity, and that's the reason why we can say, okay, the space complexity of this code is O of 1, right? So I hope you like this video. Please like, comment, subscribe, and stay tuned for my other shorting videos. Thank you.